Hello everyone, welcome to Command Line. In this course, we are going to learn about multi-threading using Python. Multi-threading is very important concept in system design because it is not just a programming construct. The entire distributed architecture, the entire distributed system architecture is built on the concepts of multi-threading. So, once you master multi-threading with Python, you can actually able to simulate distributed systems, introduce delays and latencies, and actually do some experiments and understand the distributed system very well. First of all, we have to understand what is a thread and how it is different than a traditional process. The modern operating systems like Linux or Windows are giving a very good abstraction layer around a process. Let's consider process A. Let's say this is process A. We have a code something like A equal to 10, B equal to 20, and C equal to A plus B. Right. And we have another process B. Let's say the code here is x equal to 2, y equal to 3, z equal to x times y. So here these two process A and process B are independent from each other. So anything happens in process A will not affect the process B. So this is being achieved using virtual memory. We can see that when you learn more about OS related concepts. Anything happens here, like for example, if the process A says z equal to 100, if there is another instruction being added into process A, that is not going to affect the z in process B because the z in process A and z in process B are completely independent. So if process A and process B wants to communicate to each other, they cannot simply share variables. They have to use something known as inter-process communication or IPC. The IPC is being enabled by the operating system itself. So this is abstraction layer I'm talking about. Every OS, every modern OS, Linux, Windows, or Mac, whatever you take, that is providing this abstraction layer around every process it is running on the machine. So if you notice cleanly, like if you watch very cleanly, you can see there are two parts of a process. So this is the logic part. So here are the instructions. Instruction A equal 10, B equal 20, C equal to A plus B. Along with that, there is a data part. So A, which is going to store 10, and B, which is going to store 20, and C, which is going to store 200. So every process you see, there is a logic part and there is a data part. Similarly, for process B also you can see there is X, which is going to store 2, and Y, which is going to store 3, and Z, which is going to store 2 times 3, nothing but 6. And this new instruction Z equal to 100 is going to create another data part here. So another data part with Z equal to 100 will be created inside this process data part. It is not going to affect the data part of other process. This is how the processes are actually being protected from one another. Okay, now let's see some other way. Like let's consider a special process. Let's say something as x equal to 10 and y equal to 20, and there are, let's say there are going to be two logic parts. One logic part says z equal to 10 sorry x times y, and other logic part says z equal to x plus y. So you consider this as the process, and there are two logic parts, and importantly both the logic parts are going to share same data part. So this is logic 1 and this is logic 2, and this is a unified data part. So here we will be having x 10 and y 20. There will be a box for z, but the value inside z is not determined by which instruction runs first. So these are two logic parts, right? Both logic parts can be independent from one another. They can be overlapping. So we cannot say whether this will run first or this will run first. If this runs first and this runs second, then the output will have this value, which is nothing but x plus y, which is nothing but 30. Suppose for some reason this logic one is slower, sorry, this is faster, it gets executed first, and it's executed second, then the value will be 200 here. So this is called threads. So let's not worry about how the data getting don't worry about the data is getting mismanaged here. We will see about all those things in the upcoming videos, but the concept is simple. So if a single process, let's say this is process C, if a single process has two logic parts or more than one logic part which is going to work on same data part which is unified, then that program is called multi-threaded programming. Every logic part here is called as threads. So this is thread 1 and this is thread 2. This is a concept. So in the program side, in the process side, every process will have independent logic part and independent data part, and they are not overlapping with one another. Suppose there are two processes, they are sharing the data part. In Linux, actually threads are being implemented using process struct only. So actually the concept is same. So if there is a process or if there are two processes, they are going to work on a unified data part. So like this, you can consider each logic part like an independent process. And these two independent logic parts are going to work on a unified data part. So the address space is going to be same. Then it is a multi-threaded programming. Every independent logic part, the logic part 1 and the logic part 2, both independent logic parts are called as threads. So let's see another simple coding based example. So let's say we are having a code something like def main x equal to 10, y equal to 20, and then add x comma y, then multiply x comma y. So if this is the program, the execution happens from top to bottom. We know this, it is happening sequentially. So first it will be x will be assigned with value 10 and y will be assigned with 20, and the instructions inside the add function will be executed first. Only when the function add completes its execution, the instructions inside multiply will actually start executing. So this is sequential programming. It is a single threaded sequential programming. These two run in an order. So we can deterministically say every time that the multiplication will happen only after the addition. We can clearly say the order. In a single threaded sequential execution, we can clearly tell the order. The addition happens first and then the multiplication happens. So it will never happen. You run this program 100 times, 1000 times, even a million times, the order is not at all going to change. Suppose you have another program. Let's say, don't worry about syntax right now. Let's say something like def main, and again same, x equal to 10, y equal to 20, and thread. Let's say we are going to create a new thread using add function. So as I said, don't worry about syntax. We are going to see syntax in the next video. 10 comma 20, sorry, let's pass x comma y, and then thread of multiply x comma y. So even though the code looks sequential, it is not actually sequential, because we are creating threads. We are firing off a different thread from here, and this thread is going to run independent from this thread. We cannot be able to determine the order here. That order is purely based on system state. So what actually happens here is, let me just try to put that in a diagrammatic structure. So let's say when the program actually starts, when you are actually starting from here, so we are having only one thread, we call it as a main thread, and that main thread is running on CPU 0. So let's call it as CPU 0. So I'll put that lines so it will look like a CPU. And this particular sequence of execution, we are assigning x equal to 10, y equal to 20. This is happening in the order. So after these two instructions completed, the third instruction comes, thread add of a comma x comma y, right? So at this point, a new thread is spanned across, and this is going to another CPU, maybe CPU1. Let's put the pins here. And this is going to execute the add function. The add function is not running on the main thread at all, and main thread is continuing executing. So it didn't stop from here, it is a branched out, but still the main thread, the instruction in CPU 0, this is CPU 0, is continuing execution. And after this point, here we are running the next instruction, thread of multiply x comma y, that is firing another branch, and that is going to CPU 2. Let's say like it doesn't need to go to exact CPU numbers in the order, but just for understanding, I'm just telling it's going to CPU 2. And this execution actually runs the instructions inside the multiply function. So 1, 2, 3, all three will run in parallel. So we can call it as like the main thread and thread 1, thread 2. So you can see we actually created 2 threads, but actually there are 3 threads, because the program itself is running on one independent thread. When there are no threads in the process, it means there is at least one thread in the process. The logic part in the process is running its own independent thread. So that is a main thread. Along with that, we are spanning 2 more new threads, and both threads are spanning into thread 1 and thread 2. And because these are running in 3 different processors, so it is a multi-core system. In the multi-core system, 3 different threads can run on 3 different hardware. So now who is going to run first is purely depending on the load on those CPUs. If CPU 1 is actually loaded, there are some other instructions already running on CPU 1, but CPU 2 is, there are no, it is much more freer. There is no instruction running on the CPU. In that case, who will run first? Obviously CPU 2 will run. No? The multiply will be executed in CPU 2 because CPU 2 is free, but CPU 1 is not free. So add has to wait in the queue to get into CPU, but mul will actually get into CPU 2 immediately, and multiply will run first. Even though we call multiply second time, the multiply runs first purely based on the load of the CPU. That's why the multi-thread, they are parallel executions, and we cannot clearly determine who is going to run first, who is going to run last. That is purely depending on the system state. So when you run a multi-threaded programming multiple times, you will see different order of execution. In a sequential programming, for example, in this code, how many times you run, even million times you run, the order is not at all going to change. But this program, if you run, maybe the first time the add will run first, but on the 5th time the mul will run first. So the order of execution will change. And why you want to go into this confusion state, we will see about it. I will explain why we are actually breaking the sequential logic into parallel. What is the advantage we are going to get from that in the next video. So the core concept we have to understand now is every process has 2 parts. A process is having a data part and a logic part. And if a process has more than one logic part, then it is a multi-threaded. And all the logic parts, they are independent from one another. They are not depending on, their execution order is not at all going to be determined by one another. They are independent. And the order of execution is purely depending on the state of the system. So not related to the program, it is purely based on state of the system at the time of execution. So you run multiple times, you are going to get different results, different order of execution. And all these logic parts are going to work on the unified data part. they all work on the unified data part. So this is the core concept of multi-threading, and the same concept extrapolates to distributed computing, where usually we call the logic part as compute or stateless, or the data part as data or states. And here in the multi-threading programming, we are seeing these independent logic parts are running on two different CPUs on the same machine. But when you go to distributed system computing, they are going to run on two different CPUs in two different machines. And those machines can be across two different data centers, or they can be across two different continents. And all the problems we are going to see in the multi-threaded programming are going to be extrapolated and multi-folded in the distributed system. We are going to see all those things in the upcoming videos. So to not to miss those details, please subscribe to this channel, and thank you.